Good morning and Assalamu alaikum. Hope all of you are fine and safe. And welcome back to physics class. In today's class, we are going to learn about torque and principle of movements. Let's move towards the lecture. So in this picture, you can see that an instrument, if you are apply a force of any kind of a nut or bolt, then you are using this instrument. It means you are applying a force to open or close any kind of a nut or fix the nut. So that's why you are using the force. If the length of your instrument is longer, then you are using or you apply extra force on the nut to fix it. It means what is torque? Simply you can say that the force will multiply with the length equal to torque. Means if the length is higher, then the extra force will apply on the instruments or the object. So just as force is what causes an object to accelerate in linear kinematics, torque is what causes an object. It means torque is a vector quantity because you know that what is the where you are using the force and what is the direction of the force. So that's why it's a vector quantity. There is an example. It means if you are applying a force, it causes a movement. So the distance is very important. Very important means you can say that torque is a twisting force that tends or cause rotation in any kind of object. So the point where the object rotates is known as the axis. So mathematically we can say that T is equal to F and R, which is sine theta. Okay, so what will be the unit of torque? It is Newton meters. So how we are going to calculate the torque? There is a practical. In this practical you can see that T is equal to R multiplied by F. So a practical way to calculate the magnitude of a torque is to first determine the lever arm and then multiply it times the applied force. So if you are applying a force, you will multiply your force with the time, then you get, if you are using the lever arm in a perpendicular distance from the axis of rotation. So the lines of action of a force and the magnitude of the torque equal to the T and Newton meter. So what is a lever arm and how we are going to use it, and what is the basic work of it, and how we are going to combine the torque with the lever arm. So the torque on any kind of if you are saying the any kind of instrument, so then force will multiply with the lever arm. In the first picture you can see that the maximum torque is produced when the force is perpendicular to the instrument and it's equal to 90. After that, when it is moved little bit upward side, then you can see the force is applied and reduce lever arm. It means the torque will reduced. So in the third picture you can see that the instrument is maximum on 90 degree. So the torque approaches with 0 with the angle between the force and the instrument. After that you can see that in the last picture the lever arm is equal to R. So it means that force is applied and which will be multiplied with the lever arm. Then we get a torque, the value of the torque. So the torque is equal to T, and T is equal to R, F and sine. So lever arm is equal to R sine. So the point of application of the force, it means if you are applying a force F, so reduce from the axis of rotation to point of application of the force. Then what we get as a result, lever arm is, maybe the result is the nuts or the object will open or close. So it means when you are applying a force of any kind of the object in which the force is move in circle position, so it's called torque. Basically, if it is your force is applied in circular motion or twisting, it's equal to torque. Basically, this phenomena is called torque. So the magnitude of a torque with respect to the given axis of rotation can be approached as the first time that the lever arm with respect to that axis. It means moment arm and your force. So the lever arm is a perpendicular of the distance from the axis of rotation to the line of action of force. So the direction of a torque is given by the right hand rule. You know about the right hand rule. So let's move towards the principle of movements, which is the second topic of the day. In the picture you can see there two persons or two objects are here. So if the weight of the first person is A is 1000 Newton and B1 is 500 Newton. So how can you say that they are in a right position? So it means the principle of momentum said that when body is balanced, the total clockwise movement about the point equals to the total anti-clockwise movement about the same point. So the moment will be equal to the force will be multiplied with the perpendicular distance from the point. So what is the principle of a movement? If the anti-clockwise moment and clockwise moment are equal, then the seesaw is balanced. This is known as a principle of movement. You know that if you are using a seesaw or you are playing on seesaw, so your partner or your friend, if your weight is 20 or 30 kg and your partner weight is 40 kg, so how can you say that you are enjoying seesaw? It will not easy for you and to balance yourself. So how we are going to balance ourselves? This is the question of the day, that how can we balance ourselves on the seesaw if my weight is 30 kg and the weight of my friend is 40 or 45 kg. So when something is balanced, so we are going to say that total clockwise movement equal to the total anti-clockwise movement. There is an experiment to testing the principle of movements. In this experiment, you can see just like a instrument like a seesaw. So the balance, the ruler. If you put a ruler of any kind of with any kind of object, then you can see that where is the midpoint of it, where you are going to fix the ruler. So if necessary, you can add a plastic, rubber, or any kind of a thing to bond or the thing or the ruler with the object. Then you add the weight as shown in the figure. So move on of the weights until the rural balance. Measure the distance and record your results in a table. Do this several times with different weight and different distances. This is a practical work which you are going to do at your home, and do it please. Then after that, send me your results and tell me that what you got from this experiment. Okay, so here we have principle of movements. Clockwise movement, all the values of the clockwise movement, we are going to take them as a positive value, and anti-clockwise movements, the value of these will be we are going to take them as a negative value. Okay, there in this picture you can see our object, and the force which is applied on it. So on upper side we have 0.5 meter and 1.0. If you are going to apply any kind of a force on it, then what you get? So all the forces are equal to 10 Newton. Now let's move towards the mathematical shape of this. Total movement about P is 10 into 0.5 plus 10 multiplied by 1.5, and after that equal to these values, which means they will be that we are going to multiply also the force. Then what we get, it is just in front of you, 5 plus 15 and 10 minus 40, which is equal to minus 30 Newton meter. Minus 30 means that it is the force which is applied, it is anti-clockwise. That's why we are going to write minus sign over here. Okay,